So, for Chapter 11, Security and Dependability, Lecture 1. Topics covered would be dependability properties, availability and reliability, safety, and security. So, system dependability. For many computer-based systems, the most important system property is the dependability of the system. The dependability of a system reflects the user's degree of trust in that system. It reflects the extent of the user's confidence that it will operate as users expect and that it will not fail in normal use. Dependability covers the related system attributes of reliability, availability, and security. These are all interdependent. So, system dependability, sabi dito, ito daw yung pinakamahalagang trait ng isang system. Dependability means capable of being trusted or depended on. System dependability refers dun sa ability ng system na mag-function properly even in the presence of faults or errors. Mapagkakatiwalaan ba yung system? Reliable ba? Nagra-run ba siya ayon sa expectation ng users? And if nami-meet niya ba yung lahat ng requirements or needs ng users? So next, importance of dependability. System failures may have widespread effects with large numbers of people affected by the failure. Systems that are not dependable and are unreliable, unsafe, or insecure may be rejected by their users. The cost of system failure may be very high if the failure leads to economic losses or physical damage. Undependable systems may cause information loss with a high consequent recovery loss. So, once na nag-fail yung system nyo, hindi lang kayo yung madadamay. Maraming users yung maaabala. And syempre, pag hindi mapagkakatiwalaan yung software nyo, hindi maganda yung feedback, so pangit din yung magiging reputation nyo. So, sino ba namang gustong gumamit ng software nyo pag ganun, diba? So, we have 3 causes of failure. Hardware failure, software failure, and operational failure. Hardware failure refers to a situation where a physical component of a computer system or other electronic device stops functioning properly. Software failure occurs when a software system does not behave as intended or expected. It can occur due to a variety of reasons, such as errors in the design or implementation of the software, hardware failures, or environmental factors like power outages or network disruptions. Operational failure refers to a situation where an organization fails to deliver its products or services as intended, leading to disruptions in its operations. This can occur due to various reasons such as human error, equipment failure, communication breakdown, or natural disasters. So, principal dependability properties. Dependability, nakapaloob dito yung mga principal properties niya ay availability, reliability, safety, and security. Availability is the ability of the system to deliver services when requested. So, availability, normally, 24/7, dapat accessible yung system nyo. Kumbaga, kahit kailan gustong gamitin ni user, dapat available siya. Reliability, the ability of the system to deliver services as specified. Reliability means if nagra-run ba yung system as expected by the users. Safety, the ability of the system to operate without catastrophic failure. Safety means hindi ba siya makakakos ng harm or damage sa users. Security, the ability of the system to protect itself against accidental or deliberate intrusion. So, security, kung gaano ka-secure yung system. If safe ba siya or if kaya niya bang i-protect yung sarili niya against unauthorized access. Siyempre, as a user, ayaw naman nating manakaw na lang bigla yung mga sensitive infos like passwords or personal infos natin. Next. So, yan din siya ulit. Yung 4. sabi ko na. Then, ito, other dependability properties. Repairability reflects the extent to which the system can be repaired in the event of a failure. Repairability, kung gaano kadali o kabilis ayusin yung error. Nakadepende rin kasi sa magagastos yung kung gaano kabilis maayos. If mabilis, syempre mas konti rin yung effort na gugugulin ng developers. So, mas konti yung cost. Maintainability reflects the extent to which the system can be adapted to new requirements. Maintainability, if kaya ba siyang ma-maintain kahit madagdagan ng panibagong requirements. Yung kahit magdagdag ng panibagong feature, ganyan, o button, let's say, dapat hindi magugulo yung design or overall, hindi siya magugulo. Hindi mahihirapan yung developers na ayusin. Survivability reflects the extent to which the system can deliver services whilst under hostile attack. Survivability refers to its ability to continue functioning even in the face of extreme or unexpected circumstance. Error tolerance reflects the extent to which user input errors can be avoided and tolerated. Error tolerance is the ability to continue functioning despite errors or mistakes in its operation. A system with good error tolerance is one that can detect and correct errors as they occur without significant impact on its performance or reliability. Next. Okay, naulit-ulit yun. Ito rin siya ang 4. Skip ko na. So, dependability attribute dependencies. Safe system operation depends on the system being available and operating reliably. A system may be unreliable because its data has been corrupted by an external attack. Denial of service attacks on a system are intended to make it unavailable. If a system is infected with a virus, you cannot be confident in its reliability or safety. So, once na may history na yung system nyo na nagkaroon ng external attack, na hack ganun, magiging unreliable na yon sa paningin ng mga users. Next. Dependability cost. Dependability costs tend to increase exponentially as increasing levels of dependability are required. There are 2 reasons for this. The use of more expensive development techniques and the hardware that are required to achieve the higher levels of dependability. Second, the increased testing and system validation that is required to convince the system client and regulators that the required levels of dependability have been achieved. So, dependability cost, kumbaga, equivalent ng mataas na level of dependability ay mataas na cost or gastos rin para sa system. So, once na gusto nila ng mataas na level of dependability, mataas din yung magagastos or malaki rin yung magagastos para sa system. Next. Yan. Ganun sinabi ko kanina. Once na mataas yung dependability, mataas din yung cost. Nakikita nyo naman dyan sa graph na yan. Next. Dependability economics. Because of very high cost of dependability achievement, it may be more cost-effective to accept untrustworthy systems and pay for failure costs. However, this depends on social and political factors. A reputation for products that can't be trusted may lose future business. Depends on system type. For business systems in particular, modest levels of dependability may be adequate. So, sabi dito, since mahal yung magagastos pag mataas yung level ng dependability, it may be more cost effective. Mas makakatipid daw sila if tatanggap na lang sila ng untrustworthy na system tapos magbayad na lang for failure cost. Kaso, syempre, if untrustworthy yung system nyo, malaki yung chance na mag-fail yung buong operation nyo. Malulugi kayo, ganon. For business systems naman daw, okay na yung modest as long as decente yung system nyo, okay na yun, accepted na yun. Next, ito na sabi ko na kanina, availability and reliability. So, perceptions of reliability. The formal definition of reliability does not always reflect the user's perception of a system's reliability. So may cases daw na magkaiba yung meaning ng reliability sa developer at sa users. Like, maaring pumasa yung reliability sa developer, yung reliability ng system, pero pwedeng hindi yun yung hinahanap na reliability ng users. Next, reliability and specifications. Nasabi ko na rin yung reliability. Key points. Dito na tayo sa lecture 2. Faults and failures. Failures are usually a result of system errors that are derived from faults in the system. However, faults do not necessarily result in system errors. Errors do not necessarily lead to system failure. So, sabi dito, usually daw, yung faults ay nagre-result ng system errors, and yung system errors naman nagre-result sa failures. But, sabi dito, hindi lahat ng faults nagre-result sa system error. Same din na hindi lahat ng error nauuwi sa system failure. Reliability in use. Removing X% of the faults in a system will not necessarily improve the reliability by X%. A study at IBM showed that removing 60% of product defects resulted in a 3% improvement in reliability. Sabi dito, once na na-remove mo yung, let's say, 50% fault sa system, it doesn't necessarily mean na magiging 50% na rin yung reliability. Kasi hindi lang naman yun yung sukatan para masabi if reliable ba yung system mo. Maraming kailangan i-consider na factor. Next. Reliability achievement. Fault avoidance. Development techniques are used that either minimize the possibility of mistakes or trap mistakes before they result in the introduction of system faults. Fault detection and removal. Verification and validation techniques that increase the probability of detecting and correcting errors before the system goes into service are used. Fault tolerance. Runtime techniques are used to ensure that system faults do not result in system errors and or that system errors do not lead to system failures. So, fault avoidance. Habang gumagawa ng system, syempre hindi natin may iwasan na magkaroon ng error or faults. Normal yon. Nasa sa inyo yon, nasa sa team nyo, kung paano nyo may iwasan or mami-minimize yung mistakes bago mauwi sa system faults. So, safety. Nasabi ko na rin to kanina. Safety means yung ability ng system na mag-function without causing harm sa user or sa human. Without injury, human injury or death, sabi dito, and without damage to the system's environment. Next. Safety criticality. Primary safety critical systems. Embedded software systems whose failure can cause the associated hardware to fail and directly threaten people. Example is the insulin pump control system. A primary safety critical system is a system that is designed to perform a critical safety function in order to protect people, property, or the environment. These systems are typically used in high-risk industries such as aviation, nuclear power plants, medical devices, and transportation. Primary safety critical systems are designed with multiple levels of redundancy to ensure that they can continue to operate even if one or more components fail. They are also subject to rigorous testing and certification processes to ensure their reliability and safety. Examples ng mga primary safety critical systems include air traffic control systems. These systems are responsible for ensuring the safe and efficient movement of aircraft in the sky and on the ground. Pangalawa is nuclear power plant control systems. These systems are responsible for controlling the operation of a nuclear power plant to ensure that it is operated safely and efficiently. Medical device control systems gaya ng insulin pump control system. These systems are responsible for controlling medical devices such as pacemakers, ventilators, insulin pumps, gaya na sabi ko kanina, to ensure that they operate safely and correctly. Transportation control systems. These systems are responsible for controlling transportation systems such as trains, buses, and subways to ensure that they operate safely and efficiently. So, secondary safety critical systems. Systems whose failure results in faults in other socio-technical systems which can then have safety consequences. For example, the MHC PMS is safety critical as failure may lead to inappropriate treatment being prescribed. A secondary safety critical system is a system that is designed to provide additional layers of safety protection to a primary safety critical system. These systems are also important in high-risk industries where the failure of a primary safety critical system can have serious consequences. The purpose of a secondary safety critical system is to mitigate the risk of a potential failure of a primary safety critical system. These can be achieved through redundancy, backup systems, or other safety measures that are designed to activate in the event of a failure of the primary systems. Example naman ng mga secondary safety critical systems include emergency backup power systems. These systems provide backup power in the event of a power outage or failure of the primary power system. They are commonly used in hospitals, data centers, and other critical infrastructure facilities. Isa ulit sa mga example ay emergency shutdown systems. These systems are designed to shut down equipment or processes in the event of a safety hazard or malfunction. They are commonly used in industrial plants, oil refineries, and chemical processing facilities. Isa ulit sa examples ay fire suppression systems. These systems are designed to detect and suppress fires before they can spread and cause further damage. They are commonly used in buildings, aircraft, and other high-risk environments. Isa ulit sa mga example ay backup communication systems. These systems provide redundant communication channels in the event of a failure of the primary communication system. They are commonly used in aviation, military, and emergency response applications. Safety and reliability. Safety and reliability are related but distinct. In general, reliability and availability are necessary but not sufficient conditions for system safety. Reliability is concerned with conformance to a given specification and delivery of service, while safety is concerned with ensuring system cannot cause damage irrespective of whether or not it conforms to its specification. Safety and reliability are related concepts, but they have different meanings and implications. Safety refers to the ability of a system to operate without causing harm to people, property, or the environment. A system is considered safe if it can perform its intended function without causing accidents, injuries, or damage. Safety is an important consideration in high-risk industries such as aviation, healthcare, transportation, and nuclear power. Safety is typically achieved through the use of safety-critical components, safety systems, redundancy, and fail-safe design. Reliability, on the other hand, refers to the ability of a system to perform its intended function consistently and predictably over time. A reliable system is one that can operate as intended without failure or breakdown. Reliability is important in all industries where performance is critical, such as transportation, manufacturing, and energy production. Reliability is typically achieved through the use of high-quality components, regular maintenance, and testing. While safety and reliability are related, they are not interchangeable. A system can be reliable but not safe if it is not designed to prevent accidents or mitigate their consequences. Similarly, a system can be safe but not reliable if it is prone to failure or breakdown. In practice, achieving both safety and reliability requires careful engineering and design, as well as ongoing maintenance and testing to ensure that the system performs as intended under all conditions. Unsafe reliable systems. There may be dormant faults in a system that are undetected for many years and only rarely arise. Specification errors. If the system specification is incorrect, then the system can behave as specified but still cause an accident. Hardware failures generating spurious inputs. Hard to anticipate in the specification. Context-sensitive commands, issuing the right command at the wrong time, often the result of operator error. Unsafe reliable systems are systems that are designed to operate reliably but that have the potential to cause harm to people, property, or the environment if they fail. These systems can be particularly dangerous because they give the impression of being safe and reliable even though they have the potential to cause serious accidents or disasters. An example of an unsafe, reliable system is a backup generator in a hospital. While the generator is designed to provide backup power in the event of a power outage, it may also emit carbon monoxide if it is not properly ventilated. This can pose a serious health hazard to patients and staff if the generator fails and the carbon monoxide is released into the building. Another example of an unsafe reliable system is an aircraft that has been designed to operate safely and reliably, but that may experience a catastrophic failure if it encounters unexpected weather conditions or other unforeseen circumstances. In this case, the aircraft may be reliable under normal operating conditions, but it may not be safe under all possible conditions. To address the risk associated with unsafe reliable systems, it is important to implement additional safety measures and safeguards. These can include redundancy, backup systems, and fail-safe design principles. It is also important to conduct regular maintenance and testing to ensure that the system is operating as intended and to identify any potential safety hazards before they can cause harm. Safety achievement, hazard avoidance. The system is designed so that some classes of hazard simply cannot arise. Ang primary goal ng hazard avoidance is to identify potential hazards and implement measures para ma-prevent or mitigate the consequences of those hazards. Hazard detection and removal. Ang primary goal naman ng hazard detection is to identify potential hazards before they can cause harm, while the goal of hazard removal is to eliminate or mitigate those hazards once they have been identified. Damage limitation. The goal of damage limitation is to reduce the extent and severity of the damage caused by an accident or incident, as well as to prevent the incident from escalating and causing further harm. Next, normal accidents. Normal accidents. The concept of normal accidents in a system refers to the idea that complex systems are inherently vulnerable to unpredictable and catastrophic failures even when they are designed to be as safe as possible. Normal accidents occur in complex systems because they have multiple interacting components and are subject to a high degree of uncertainty and variability. This makes it impossible to anticipate and prevent all potential failures, and even seemingly minor failures can cascade and lead to catastrophic events. Security. The security of a system is a system property that reflects the system's ability to protect itself from accidental or deliberate external attacks. Gaya ng sabi ko kanina, security refers to its ability to protect itself and its data from unauthorized access, use, disclosure, disruption, modification, or destruction. Security ay isa sa mga critical aspects ng kahit anong system. Once na na-access ng unauthorized na tao yung system nyo, it can lead to a range of negative consequences including data breach, theft, fraud, or damage to the system's reputation and trustworthiness. Fundamental security. If a system is a network system and is insecure, then statements about its reliability and its safety are unreliable. The fundamental security of a system involves ensuring confidentiality, integrity, availability, authentication, authorization, resilience, and privacy ng system. Threat classes. Threats to the confidentiality of the system and its data. Threats to the integrity of the system and its data. Threats to the availability of the system and its data. Threat classes refers to the categories of potential threats that a system may face. Isa na ron ay human threats like hackers, environmental threats like natural disasters, and technical threats like viruses. Damage from insecurity. So, ito yung mga possible damages pag insecure yung system. Denial of service. The system is forced into a state where normal services are unavailable or where service provision is significantly degraded. Corruptions of programs or data. The programs or data in the system may be modified in an unauthorized way. So, pwedeng mabura o ma-modify yung mga data na nakasave sa system in an unauthorized way. Disclosure of confidential information. Information that is managed by the system may be exposed to people who are not authorized to read or use that information. So, malileak yung sensitive infos like passwords or even personal information na minamanage ng system. Next, security assurance. Vulnerability avoidance. The system is designed so that vulnerabilities do not occur. So, vulnerability is a weakness in a system na pwedeng i-exploit ng attacker to compromise the security and integrity of the system. Vulnerability avoidance is an essential aspect of maintaining the security and resilience of a system. So, attack detection and elimination. The system is designed so that attacks on vulnerabilities are detected and neutralized before they result in an exposure. So, nakadesign daw yung system na ma-detect if ever atakihin yung vulnerabilities ng system and ma-prevent yung attack bago makaharm sa system. Exposure limitation and recovery. The system is designed so that the adverse consequence of a successful attack are minimized. So, security accidents can still occur kahit gaano kalaki yung effort mo to prevent them. That's why, sa isang system, dapat daw may mga safety measures like data backups para if ever man na magkaroon ng security attack, hindi ganun kalaki yung magiging damage. Next, key points. That's all. Thank you.